I know. Another video. Um, I wanted to show you the Delta Math assignment. It's actually pretty cool, their perspective on how they show how to work these out. In the examples and the videos that I did with you, I taught you the ratios and then how to go backwards and forwards through the ratios. If that's too much, there's a whole nother perspective, and it's about similar triangles and setting up proportions. So let me show you what I'm talking about. In this particular problem, you might get on Delta Math, you might not, but it says find the length of side x in simplest radical form with a rational denominator. All right, meaning no radicals in the denominator. So right here we have a 30, 60, 90. This is the short leg, and the x is the long leg. And so the way I taught you was, you can think about it like this. Then I said, okay, you can put the x in there. This is the short leg, this is the long leg, and this is the hypotenuse. And we always want to get back to the short leg. And in this example, we know the short leg. The short leg is 7. Let me use a different color. Okay, there we go. It's 7. So to get to the long leg, we simply just apply the radical 3 to it. So that's pretty simple. When I get down, let's see. Okay, so then I would do 7 radical 3, hit enter. Okay, let me clear. There's got to be a quick way. Let's see. Let me clear all this. Whoa! No, you don't like to watch me clear all this. If I leave a little bit, it'll drive you crazy, some of you. So, okay. All right, so yes, I got it right. Now look how they explain it. So we know that the problem they gave us, is similar to the standard 30, 60, 90 triangle, which has the ratios on it, the 1, 1 root 3, and 2. And so you can set up a proportion. So if we're trying to find x, what they did is they said x is to 7, so this is to 7 as radical 3 is to 1. So they set up a proportion. See that? And you cross multiply and you get x is 7 radical 3. Now I know in this particular example, it's super simple and we could just do this one quickly. But what about a different one? So what if I did a new problem? Okay. All right, so this one might be a little more tricky. Right here, we are given a 30, 60, 90. We have the hypotenuse, okay? So we have, this is the hypotenuse, and this x is across from the 60 degrees. So this is the long leg, LL. And so in the examples that I gave you, I would have said, oh no, we have this. And we know the hypotenuse is 7, and we want the long leg. So how do we get back there? Well, we would have to do some work. We'd have to get back to the short leg first, so divide by 2. So the short leg would be 3.5 or 7/2. And then we would have to apply the radical 3 to that. So times radical 3. So it'd be 7 radical 3 over 2. When I go and type that in, 7 radical 3. I know in the past I've had some of you have a hard time with fractions. Hit Control A, just select it all, and then hit the division symbol and put the 2. I submit my answer, and it's right. Okay. Now, what I wanted to show you was this whole standard triangle similarity thing. So here's the problem. Here's the standard triangle. And so look, we can set it up, as long as intuitive, we can set it up. They did x is to 7. So x is to 7. If we do that, x is to 7. And that's from this triangle. What would I have to do from this triangle? Well, x is on the bottom, so that would be radical 3 on the bottom. And then 7 is the hypotenuse, so 2. So that would be my setup. And there we go. See, they've got that same setup that I had in blue and purple. They have it right here, and they cross multiply. They actually didn't show the step after the cross multiplying. You would get 2x equals 7 radical 3, and then you would have to divide by 2. Divide by 2, and you get x is 7 radical 3 over 2 like we got. So I just wanted to show you that you can set it up as a proportion. Awesome job.